This is Relatively Prime, carrying the two in the mathematical domain. I am Sam Hansen.
And I am Sadie Witkowski.
That's right, you're getting two hosts for the price of one on this sort of Relatively Prime. As all of you have probably noticed, or not noticed because no episode has shown up for 4 years, Relatively Prime has been on a bit of a hiatus. There's a lot of reasons behind this, and I am currently planning on bringing Relatively Prime back sometime soon. I just don't have it fully finalized yet. So keep an eye out on this feed. But until then, I want to share something that I've been doing with Sadie, and that is the podcast Carry the Two.
We've been carrying on our own math show.
That's right. And Sadie, as the founder of Carry the Two, can you tell the Relatively Prime audience just a little bit about it?
Yeah. So we found it, or I and a separate co-host who left me for Germany founded the Carry the Two podcast as a way to communicate the importance of mathematical and statistical research for people who think that they don't like math or that it doesn't impact their lives. We kind of do the classic journalism style of we got to put a lot of cheese on your broccoli. That's my favorite phrase for that, where we talk about all the fun, interesting ways it intersects with the world around us. So we've done seasons on climate change. We've done seasons on Hollywood and its use in special effects. And right now we've got a really fun season going on, although I won't lie, it stresses me out a little bit.
I mean, that is fair. One thing we should add is that Carry the Two is done as a podcast for the Institute for Mathematical and Statistical Innovation, which is one of the NSF-funded mathematical research institutes. In particular, IMSI, or IMSI as we call it, is hosted on the campus of University of Chicago. And it has all sorts of programs and things. You should really check it out. The website is imsi.institute, where you can find the podcast, but also find all the cool programs. And you could say, come visit me, because while Sadie was their director of communications in the beginning, I have since taken over that role. Isn't that right?
Yeah, it was a very appropriate passing of the torch, I think. And I'm excited we still both get to work on this together because it is a fun project.
Oh, so am I. And as Sadie said, we have a very exciting season going on right now. Also a very stressful season because it is almost November of 2024. And our season is all about the mathematics of democracy and politics.
Yeah, super low key, not important at all topic.
And so, Sadie, what are some of the topics that we have covered so far?
Yeah, I mean, like there's the obvious, how do our votes get counted? And is there a better way to count our votes, especially looking at, for example, the presidential election and how we have an electoral college? Also, one of my personal pet peeves that I argue with people all the time, I loved covering gerrymandering and how our political maps are created. And yeah, it's just been fun, and I've been learning more every time.
And for those of you who have listened to all of Relatively Prime and might be a little bit done with the idea of the mathematics of gerrymandering, don't worry. This was an entire new focus, specifically on communities of interest and how mathematics has been used to help better grasp their shape in ways that we haven't been able to up till now.
Yeah, it was really interesting to think about. Not only is it just, these squiggly lines don't make sense, but it's actually when we live in communities that have shared interests, how do we make sure those shared interests are actually represented? And sometimes those are geographic and sometimes they're cultural, but how do we represent that on a map? Like, it's a thing I think about a lot with such a neighborhood heavy area that Chicago is.
Yes. And so what we are doing for you today is having this short conversation between me and Sadie to sort of introduce things. And then we are going to put the first episode of this season, which is all about voting, specifically how what mathematics has to say about whether or not voting can ever be perfect. And I'm not going to spoil the answer, but a lot of you might have an inkling.
You might guess.
So with that said, let's just have you go into the episode. And if you want to hear more, make sure to search for Carry the Two on whatever your podcast listening platform of choice is. And thank you for sticking around on the Relatively Prime feed. I do promise new Rel Primes very soon.
I'm Sadie Witkowski, and you are listening to Carry the Two, a podcast from the Institute for Mathematical and Statistical Innovation, aka IMSI. That is right. We are back. And while this is still the podcast where we talk about the real-world applications of mathematical and statistical research, I am now joined by a new co-host, Sam Hansen.
Hello, everyone. I'm so happy to be joining Sadie to talk math with y'all. It was a dream to have the opportunity to become IMSI's new Director of Communications and Engagement and come on board Carry the Two, a dream that's made even sweeter when it worked out that I would be able to co-host it with Sadie. I can't think of anyone else I would rather be on the mic with.
Thanks. I am so happy to be able to stay a part of Carry the Two. Though today I do find myself in an unfamiliar role, as I'm not entirely sure what we're going to be discussing today.
Well, as I'm sure you know, we here in the States have an election coming up. So I thought there's no better time to investigate the intersection of math and democracy.
You got a point there.
Which is why, for my first season of Carry the Two as co-host, I thought that should be our focus. And for the first episode, I knew exactly who I had to talk to.
So the name is Ismar Volić.
Ismar is a professor and chair of the mathematics department at Wellesley College, as well as the director of the Institute for Mathematics and Democracy. And most importantly for us today,
I'm the author of Making Democracy Count, How Mathematics Improves Voting, Electoral Maps, and Representation. I think I got that right. But yes, that came out just this past April.
He did indeed get that right. But today we're going to focus only on the first part of that subtitle, voting. And to do that, we're going to have to start with what, Sadie?
Well, since we're dealing with math, I'm going to guess a definition.
You got it in one.
A voting system is any mechanism by which preferences of individuals are aggregated into some choice. In this case, a choice of a candidate, right? Or a number of candidates if we're talking about multi-winner elections.
Simple enough, right? And voting systems are part of a bigger world of things called social choice functions, which are the many different ways groups decide on things. And it is why the study of voting falls under social choice theory. But let's not get too bogged down with the general and stay on the specifics of voting. Does that sound good?
That sounds perfect.
Great. With that settled, what's the first thing that pops into your head when you hear Ismar define voting systems?
I guess what voting system we end up using here in the US.
Well, lucky for you, I had that exact question. We have these social choice functions, these voting functions, will of the people and all that. How does the United States, in most cases, try to capture that through our voting system?
Well, it chooses the worst social choice function because it's at the same time the easiest. So easy is good, right? People understand it, but it's really terrible at capturing this will of the people. And that is relative majority or plurality voting or first past the post or winner take all. It has all these names because it's so widely used, not just in the United States, but in most democracies in the world to some extent. Although we and a couple of other countries use it the most, and therefore we have the worst voting system.
Oh man, he doesn't mince his words, does he?
Nope, not one bit. But let's have Ismar flesh out the specifics of plurality a little bit more.
When you say voting, this is what most people imagine. You just pick one of the candidates, and that's it. And then you move on. And the candidates with most votes wins. So that's the plurality winner.
Okay. Yeah, this sounds familiar. Why does Ismar say this is the worst?
Well, he did end up wanting to expand that a little bit.
And I should qualify the worst. When I say the worst voting system, I mean the voting system that's actually used out there.
There are other voting systems that are clearly worse. They just aren't used in democracies. One you've heard of, dictatorship. In social choice theory, dictatorship is defined as a voting system where only the dictator's vote matters, and who or whatever they vote for wins.
For sure. Definitely sounds worse than plurality.
It isn't my favorite of the worst systems, though.
You have a favorite worst voting system, Sam?
Yes, I do, and it's called parity.
Okay, we're just going to have to skip past having a favorite worst voting system because I don't think we have enough time to really dig into the psychology of that. So I guess I'll just ask what parity is instead.
Well, thank you for that question. Parity is a voting system Ismar wrote about in Making Democracy Count, where you have two candidates, A and B. And the winning condition for candidate A is that the total number of votes is even. And if the total number of votes is odd, B wins.
That's ridiculous.
I know! That's why it's my favorite. Anyway, back to plurality and why it's the worst of the best.
With three or more candidates, most votes does not mean a majority of the votes. And this is where the social choice theory opens up into a wonderful and frustrating field of mathematics and economics and political science and so on.
Ah, that makes sense. I can remember a number of very important elections where the winner had less than 50% of the vote.
Exactly. On the national stage, no candidate got above 50% of the vote in 4 out of the last 8 presidential elections. And those are elections where there really are only 2 candidates with a chance of winning, and maybe a third candidate that can pull a few percent. It gets even worse when you start thinking about elections where there are even more candidates that could win, like primaries.
Yeah, if I remember correctly, the last competitive Senate primary in Illinois had 7 candidates who all got over 5%, and the winner only got 30.2% of the vote. That doesn't really scream will of the people.
No, it doesn't, does it? And social choice theory has names for some of the problems with plurality. The first two you've probably heard of, and that's the idea of wasted votes or not wanting to vote for the candidate you most want to win because you're afraid they have no reasonable chance of winning. And thus your vote would be wasted. And spoilers, or a candidate, let's call them C, that peels off enough votes from candidate A so that they lose to candidate B, even though the people who voted for C would have preferred A to B.
Those definitely sound familiar.
The issue Ismar spoke the most about with me, though, was vote splitting.
Vote splitting is when kind of similar candidates divide the votes, allowing another candidate to kind of rise to the top and win with very few votes.
This is probably what happened in the 2020 Republican Senate primary in Illinois.
It's very likely that it was. And in the worst cases, it can get quite ridiculous.
So there was a mayor in Fall River, Massachusetts, who was pretty corrupt. It was clear that he was, taking money from donors and spending it on like lavish lifestyles and fancy cars, etc. So federal charges were brought against him, and a vote was brought to Fall River to oust him as a mayor. And that happened. But on the same ballot where people were supposed to, declare their preference whether they want to kick this guy out or not, the next question was, well, who do you want to be the mayor in case this guy is, kicked out? Well, nothing in the system actually prevented the same guy to be on the ballot for to be the mayor. You see where this is going, obviously. So he gets kicked out by a majority of the votes. I forget exactly what, 60 something. But then he gets reelected mayor with, like 30% of the vote or something because of vote splitting and plurality voting. So it really is, it's kind of a hilarious and terrible example of how these voting systems failed. He later got convicted, and I think he's in jail now or something.
Recalled and then reelected on the same ballot.
Yeah, specifically recalled by 61.45% of voters and then reelected by 35.4% of voters. And While this may be an extreme example, Ismar says there are plenty more.
So when I give talks on this stuff in various parts of the country, I will adjust my presentation to make it as local as possible. It literally takes me like a minute to Google some elections right there where I'm giving the talk and find something that potentially was, vote splitting or a spoiler or some of these other bad effects.
And it's not only not always meaningfully representing the will of the people you can blame on plurality, it also encourages polarization and negative campaigning.
So it encourages you to create a gung-ho base that you can rely on that will maybe push you over the plurality bar. It encourages a negative campaigning as well, because a vote that I can take away from you is a vote from me, right? So hurling poop at you is a strategy that pays off. So all these things do encourage polarization. Yeah.
I mean, I am convinced that plurality is bad, but how can math help?
Well, in order for math to help, we're first going to need some more definitions. Specifically, we need to mathematically define what criteria we're looking for in a voting system.
Right. Makes sense.
Thankfully, that's exactly what social choice theorists have been doing for decades. And while there are multiple sets of criteria used depending on what area of social choice theory experts are studying, there are a core set that are typically used for evaluating voting systems. One is the Condorcet criterion, which Ismar will talk more about later. Another is the majority criterion, which means if any candidate gets more than 50% of the votes, they should win. Next is the anonymity criteria.
If we were to switch ballots, the result of the election wouldn't change, right? That's a way of saying that no voters preferred over another. Everybody's equal.
The neutrality criteria.
So if candidate A was the winner and B was a loser, and we all change our preference from A to B or B to A, now B should be the winner as well.
The monotonicity criteria.
So if somebody is winning and they get more votes, they should still be winning.
And finally, Ismar defined the independence of irrelevant alternatives criteria, or IIA.
Suppose a candidate is a winner according to some tallying method, and we have these ranked ballots. If you sort of switch things around, but do not mess with the position of the winner on any of the ballots, you might change some other things around. That shouldn't change the outcome. This should still be the winner. If you fail that, then you fail IIA, namely, you're not independent of irrelevant alternatives. You're depending on something that should be relevant.
Sure, all those make sense, but it seems a little silly that we should have to check them. I mean, a winner getting more votes causing them to lose or messing around with the ordering of candidates below a winner shouldn't impact anything.
Ismar agrees, kind of.
I mean, it sounds dumb, of course, right? But it turns out not all voting systems actually satisfy this. So it's very, again, it's from an academic point of view, this is very cool, very exciting. There's something there that we want to dig into and figure out what's going on. But if you're trying to implement this in an actual democracy, you are just pissed.
And these issues really do show up in the real world. For example, IIA failed in the 1995 figure skating world championships.
So there was, there's a women's world figure skate championship, and Michelle Kwan, I think, was like the U.S. superstar at the time. She was a teen. She was young, 14 or something. And before she skated, there were these three other women who were placed first, second, and third. But then Michelle Kwan skated, came in fourth, but also the second and the third place flipped.
What?
That's what can happen if you don't choose your voting system carefully. I will say figure skating did change their voting system after that, but Michelle Kwan was again involved in an IIA issue in 2002 when she was in first ahead of Sarah Hughes until Arina Slutskaya skated, after which Hughes jumped up to first, Slutskaya got second, and Kwan tumbled to third. Skating again had to change their voting system after that.
Well, across all of these, it's clearly hard to find a perfect voting system. So again, I ask, how can math help?
Well, mathematics has proven that there is a best voting system for a very specific context.
Oh, I'm sorry. What was that?
There is a best voting system for a very specific context.
Mm-hmm. And what is that context?
When there's only two candidates,
Oh, that is rather specific.
we have to take what we can get. That there is a best possible voting system for two candidates was proven in 1952 by Kenneth May, and the result is known as May's theorem.
May's theorem says the absolute majority voting it will satisfy these three, and it's the only system that will satisfy these three. So it is kind of an unequivocal kind of case closed situation where this is the voting system we should use. We shouldn't use dictatorship or parity. Of course, we know all these things, but to have a theorem that says yes, this is the one to use, that's great.
And what about when there are more than two candidates?
Okay, I'm going to tell you, but I wanted to let Ismar share what he really thinks the big issue of plurality voting stems from.
The main issue is that plurality just doesn't know enough about our preferences. We are saying so little that there is really little that math can do. And therefore, math can make a mistake, right? In sort of in the sense of representing us faithfully.
And there are a couple of ways of gathering that information.
One is these preferential, ordinal systems or cardinal systems. So ordinal systems ask you to rank the candidates, right? So typically in a plurality election, you say who your top choice is. But here you would say that, plus you would say who's your second choice, third, etc. And then math can do various things with that. And there are cardinal voting systems where you evaluate each candidate separately somehow. You don't pit them against each other, but you provide some information about each of them independent of the other one. So you might rank each candidate on a scale from 1 to 10 or something like that. And math can do a lot more with that as well.
I needed to share that because for the rest of our conversation, we're going to be talking about ordinal voting.
Why not cardinal?
For a couple of reasons. One, because plurality alternatives, ordinal or preferential voting systems are much more commonly used in democracies, and therefore there's more data around their usage. And two, because Ismar feels rankings are just more instinctive.
I think it's more natural for us to sort of rank things. You're rarely thinking if you look at a menu in a restaurant, you're like, oh, I like, you're not giving salmon a score from 1 to 10, and like the pork chop a score from 1 to. You're like, oh, I like salmon better than pork chop, right? So it's like your brain is. I think our brain more naturally goes to comparisons than individual isolated evaluations of each alternative.
Well, I personally think salmon is a 5 and pork chops are an 8, but I understand his reasoning. And now I'm going to ask you one final time. For preferential voting systems with more than two candidates, how can math help?
Well,
and there's a theorem, famous theorem by Kenneth Arrow from 1952, I want to say, that says no ranked choice voting system will satisfy them all.
What the hell, Sam? Are you telling me we went through all of that to tell me that math says no voting systems are good?
Hold on. Arrow's theorem didn't say that they were all bad, just that none could be perfect. Remember what Ismar said earlier about plurality not having enough data. If we are instead in this world where we're getting ballots with rankings back, we have more data. And
any system that takes more information in is typically going to be a better system.
Okay. What are some of these other systems?
I thought you would never ask. The one you may have heard of is commonly called ranked choice voting or instant runoff.
Oh yeah, I've heard of that. It's used in like Maine, right?
Yeah, Maine, as well as Alaska, New York City, many other municipalities.
So how exactly does it work?
Well, instead of me, I'm just going to let Ismar explain.
So instant runoff proceeds like this. If someone gets the majority of first place votes right at the beginning, that's the winner. So there's this agreement that if someone has the majority support, they should be the winner. So let's start with that kind of assumption. If not, then you look at the person with the least number of first place votes, and basically eliminate them. You erase them from all the ballots, and then you retabulate. So what does that mean? So anyone who voted for the person who's now eliminated, their vote goes to the next person on their ballot. And now there's a shift, right? Some other people have gotten more first place votes because of this transfer. Now you count again. Does anyone now have a majority of first place votes? If yes, you're done, and if not, you repeat.
Yeah, I mean, that makes sense. What are some others?
Well, there's board account.
Board account is actually maybe more natural for people to understand. You basically assign points, right? So anytime a candidate is ranked in the first place, they get the top number of points. If there are 5 candidates, you get 4 points for first place, 3 for second, 2, 1, 0. And then you basically add up all the points, and the person with the most points wins.
Is there a case where this is actually used?
Do you know Eurovision?
Oh, yeah.
Well, Eurovision utilizes a board account system for voting, with professional and televoting from each country getting their own ballots, where their top 10 songs get 12 points, 10 points, 8 points, down to 1 for the 10th place.
Oh, God. I'm just imagining Eurovision with plurality voting. What a mess that would be.
Right? Though I did check, and it wouldn't have moved Nemo out of first place this year. Probably a good thing, because if it would have moved Bambi Thug into first place, I may have just become a plurality apologist.
Wouldn't want that.
Not at all, especially when Condorcet is out there.
Condorcet. I don't remember seeing them in Eurovision.
A bit before his time, but I would have loved to see what he came up with. Condorcet was a mathematician who had a lot to say about voting.
Condorcet is cool from a mathematical point of view, because what it does is it considers pairs of candidates, and it just looks at how that pair did compared to one another. How many people have candidate A ranked over B versus B over A? And if more people have A over B, then A is the winner of that particular pairwise contest. Now you do that for all possible pairs, right? And if there's a candidate who wins all those head-to-head contests, they are the overall winner.
Oh, wait. Didn't you mention Condorcet earlier when we were talking about the criteria for best voting systems?
I did. And what the Condorcet criteria says is that if there is a Condorcet winner, then a voting system should identify that candidate as a winner.
Condorcet sounds really great, especially since it breaks everything down to 2-person elections, and then we know from May's theorem the best way to run those elections. But I know you're going to spoil it somehow, so just tell me what's wrong with it.
Wrong with it? I wouldn't go that far, but it does have some issues. A couple are more minor, such as not always generating a winner, or that it's computationally hard to compute, especially for elections with large numbers of candidates. But the real sticking point are the cycles.
So there may not be this candidate who beats all other candidates. In fact, something worse can happen. It can happen with frequently enough that it becomes a problem. You could have what's called a Condorcet cycle, which is really for someone who is not, whose brain is not used to this kind of mathematical sort of, seemingly paradoxical behavior. The brain explodes. So what you could have is you could have 3 candidates, A, B, and C, so that in a head-to-head contest, A beats B, B beats C, but then C beats A.
Oh man, my brain is just doing some rock, paper, scissors weirdness. I need a better explanation than that.
the reason why we have a hard time processing that is because we default to, ourselves. We're rational individuals. If I like, chocolate ice cream better than strawberry and strawberry better than vanilla, then by transitivity, right, you would expect that I like whatever I said first.
Chocolate.
Chocolate to whatever I said last, vanilla. You expect that. But groups as entities are not rational in this sense of the word. Again, this is something that's academically very cool, interesting, but very frustrating in practice.
Sadie, can you remember the names of the problems that we identified with plurality voting earlier?
Yeah, I'm up for the challenge. We had wasted votes, vote splitting, spoilers, polarization, and negative campaigning.
That's right. And while Arrow proved that none of the ordinal voting systems we just discussed can meet all the mathematical criteria, they do all help with those issues. For example, let's think about polarization, vote splitting, and spoilers in the context of instant runoff.
So what happens for highly polarizing extreme candidates, you'll have the gung-ho base that will put them on top of ranked ballots, but then everybody else will put them at the bottom. And once this iterative process of elimination and shifts in votes happens, they're on the bottom for most ballots. They don't really advance up to the top. Somebody else is bubbling up to the top, eventually overtaking the base that's voted for them. So this is why the system eliminates spoilers, eliminates vote splitting.
And is this true for the other ranked systems as well?
It is. For Borda, while a strong base gets you a bunch of max point ballots, if you are polarizing, many of the rest may give you no points at all. And in Condorcet, being on top of a small amount of ballots does you no good if you're in the bottom half of the rest.
Well, that's great. I mean, these systems aren't perfect, but I can see why they're much better than what we're currently using. So, how are you going to ruin this now?
What do you mean? Why do you think I'm going to ruin this? Well, okay, sure, you're right. I do have one other thing to bring up. So far, we have been making a huge assumption.
What is that?
That voters are being honest, and that's just not something we should assume.
Strategic voting just means, or dishonest voting just means you are not voting your true preference. You have some end goal in mind, and you're marking something different than your true opinion.
In a way, we've already talked about strategic voting, such as when a voter doesn't vote for their true preference in a plurality system because of fear of a wasted vote. That's strategic voting.
Okay. And I really, really did not want to ask this again, but how can math help? Oh no, we've got some impossibility theorem, don't we?
Yep.
This is the Gibbard-Satterthwaite theorem, which says that, again, we're talking about ranked voting system. There is no strategy-proof ranked voting system. All the ranked voting systems are susceptible to strategic voting. And experts who really understand the guts of this theorem, I'm not one of them, say this is the really, truly the kind of the deepest, the hardest theorem in social choice theory. Arrow's theorem is what people know, but Gibbard-Satterthwaite is what people who know say is that's the real stuff.
Great. So there are no perfect or strategy-proof voting systems.
Nope. But there is a bright side.
It's not as much danger with large voting systems. Like when we vote for president, 150 million people voting. And if we did, say, ranked choice, like if I strategically try to flip two candidates this way, that way, it's not going to make. It would have to be a concerted effort of like a few million of us doing exactly the right thing to influence the outcome of the election.
Okay, that's good to hear.
Right? But do watch out if the chair of a small committee you're on changes the election system right before a vote. They could be trying to strategically influence the result.
Oh, I'll be sure to keep my eye out for that.
Good. And now I think we finally have the background we need to ask our final question.
And what is that question?
You know what? I think I'm just going to let Ismar ask it for us.
You are stuck with this knowledge, with this impossibility of a perfect preferential voting system, and that's fine. So now we have to work within the confines of this mathematical truth, right? And the question becomes, which system sort of fails these criteria the least? Like, what's the least bad system? And that is a question that it has been living in the academic world for 70 years and is still very much alive.
So that's it. You're just going to leave us with this still open question ending.
Just wait. Ismar had more to say.
What we do have now that we didn't 50, 60, 70 years ago is evidence from lots of elections about the frequency of failure of some of these criteria as they apply to these different voting systems.
And that evidence is quite positive for the existing implementations of instant runoff.
Lately, we have a bunch of evidence from lots of instant runoff elections that it's actually pretty good. It doesn't fail stuff. It doesn't produce unusual or kind of paradoxical results very often. So probability is very low that you will see something weird happening in an instant runoff election. So that's given us a little bit of a boost, sort of new wings to unite behind the instant runoff voting.
So is Ismar advocating instant runoff as to like where we should move?
He is. And he makes it very clear in his book that instant runoff is his preferred system. And among the theorists, we may even be approaching a sense of unanimity on this question.
What the math community seems to have decided in the last 5-10 years is to get behind instant runoff, put our own, like differences behind. And it's not that we're like lying to the world, right? Instant runoff is as good as any of these other systems. In addition, we have the empirical evidence that it doesn't screw up, really, very rarely, negligibly often. And it's already out there in the real world. So there's a new kind of a unity that I was actually just talking to one of the biggest proponents of Condorcet voting, Harvard professor and Nobel laureate Eric Maskin, who is a student of Kenneth Arrow, who proved that impossibility theorem. And Eric likes Condorcet voting, but he says, like, yeah, sure, I like it, but you know what? Let's just get behind IRV. It's good, it's great. Anything's better than plurality at this point, and this is a perfectly good system.
I can understand that. After all of this, anything that's not plurality does seem like the best way forward.
As long as it isn't parity.
Ugh, fair.
If you're enjoying the discussions we're having on this show, there's another University of Chicago Podcast Network show you should check out. It's called Big Brains. Big Brains brings you the stories behind the pivotal scientific breakthroughs and research that are reshaping our world. Change how you see the world and keep up with the latest academic thinking with Big Brains, part of the University of Chicago Podcast Network. Up to this point, we've only been talking about electing people, and there's another type of election that I want to talk to you about.
Okay, what's that?
Direct democracy is where, for every single issue that comes up, every policy we want to make a decision on, every single person gets to cast a vote in it. So you're having a referendum on every issue.
All right, so who is that?
I'll let her introduce herself.
My name is Victoria Mooers, and I'm a PhD student in economics at Columbia University.
So direct democracy are ballot measures, like the proposals we're always hearing about from California.
Ballot measures or referendums are a type of direct democracy where, for very specific, important topics, it's put to the whole electorate. There are those who believe that for a government to be truly democratic in the will of the people sense, then the people should be the ones voting on the laws, like they did in ancient Athens.
Yeah, like a classic thumbs up, thumbs down majority vote for every law.
Yeah, with or without the ability for people to abstain depending on who you ask. And when you think about it, this makes some sense, at least from a mathematical sense.
I mean, it does take away the question of voting systems. With just yes or no choices, we know thanks to May's theorem that the majority vote is the way to go.
Not only that, our old friend Condorcet gives us another reason.
The Condorcet jury theorem says that in a common interest environment, which means we all want the same outcome. There's a right and the wrong state of the world, and we all want to choose the right state of the world. We just don't know what it is. In that environment, as long as everyone's information is at least as good as random, then as the number of voters grows large, the probability that we choose the right state of the world when we vote with majority voting approaches 1.
Okay, I think I'm going to need you to break this down a little bit for me.
Yeah, there's a lot there. First, in the case of the jury theorem, it's important to know that Condorcet was thinking about situations with a true-false or right-wrong binary choice. So with that said, what the theorem is really saying is that as long as people have more than a 50% chance of choosing the right answer to a question, getting a lot of people into a room and taking their majority answer on the question gives you a really, really good chance of getting it right.
Okay, I think I get it. Let me give it a try. Using the word jury from the title, a jury with more people is likely to reach the correct guilty verdict.
Exactly. And when it comes to voting,
what Condorcet's jury theorem really gives us is that direct democracy or majority voting is very, very strong. It's very effective at choosing the right outcome. And it means that as you get towards a large electorate, it becomes very, very difficult to do better than majority voting.
This is, of course, assuming a lot of things that we can't know are true, such as there being a capital C correct way to vote on a law, and everyone having enough information to be better than a coin flip on voting the correct way.
Yeah, those are kind of big assumptions, especially the idea that there's a correct choice on a political vote.
Can't deny that this is a sticking point. The way I like to think about it is that the capital C correct way for a political vote on a law to go is if it faithfully represents the will of the people voting for it, if everyone had perfect information about the content and potential impacts of the law.
Okay, so like for the political votes, instead of the information from the theory representing the chance of a voter being correct on the truth, it's really much more about how they understand the law and its impacts.
Exactly. It's all about how well they're able to determine if it matches their will.
Okay, but this still is a lot of assumptions.
Yeah, but what other path is there?
Okay, that's a trap. That sounds like a leading question, but I'm gonna bite anyway. What about limiting the vote to just those who think we have the best information?
Have you been reading ahead? Because that's exactly what some people have suggested. It's a method called liquid democracy.
So liquid democracy, it's trying to be the golden medium between direct democracy and representative democracy. Everybody has the chance to vote on every issue. But now people also have the chance to delegate their vote on a given issue to a person of their choice.
Meaning, if you think your information is not up to snuff, you can assign your vote to someone who you think has more or better info.
I mean, it does sound really great, but has anyone tried it out?
They have. It's been tried out in a bunch of places, especially as an internal decision-making system in the pirate parties in Europe. Not to mention one of the biggest companies in the world.
Google implemented an experiment where they tried to use liquid democracy to make some internal choices about things like what snacks to have and things like this.
Okay, having worked in those offices, this is fascinating.
Right? Though using liquid democracy for a vote on snacks might not be the best usage.
When you see their results, it's really highlighted because they had, I think it was like under 5% of votes were actually delegated. And they had a huge amount of participation. Thousands of employees voted, but very few actually delegated. And that's not so surprising given that most of us know what snack we want.
Of course, if the question isn't one where the voters are likely to have a wide array of quality of information, then the delegation isn't too helpful.
Exactly. Not to mention that this was not a vote with only two choices, so it also ran into Arrow's theorem issues.
That pesky arrow always getting in the way.
I know, what a jerk of a theorem. But going back to our ideal world, where there are only two choices and a correct answer, Victoria and her collaborators were able to show that liquid democracy can be better than a full electorate direct vote.
In this world, there does exist an equilibrium in which delegation does better than majority voting.
When Victoria says in this world, she means in the model she and her collaborators created. And as it's said, all models are wrong, but some are useful. And what this useful model says is that if you know how likely the information that voters have is right, then there is a threshold value where people whose information is worse than that threshold value should delegate to an expert with better information.
So, say I exist in this world of the model, and I somehow know that my information is only like 65% likely to be right, and the threshold value for a specific election is 75%, then I should delegate.
Right, except those thresholds are probably too high.
We find that the threshold is kind of surprisingly low, at least by our intuition. And it means that in order for delegation to improve over majority voting, it's important that people don't delegate too much.
But why? To me, it would seem that the more people who delegate to high information voters, the more likely the vote would come out correct.
That's my intuition too. So I asked Victoria about it.
Many of those people say, oh, my signal had a pretty low chance of being right. Let me give it to this expert. That expert's only pulling one signal, but suddenly they have all this voting weight from everyone that delegated to them. So you're putting a lot of weight on this one signal that it isn't actually as likely to be right as the combined everyone else's signals.
Still not sure I'm there, but let me try. So if you were going to ask just one person, either the expert with, say, 75% chance of being right, or a random person from a pool of people who all have a 60% chance of being right, you would choose the one person. But if that pool of people was big enough, you should instead choose the pool's majority choice.
You're there. Really, it comes down to how probability and large numbers interact. The more independent voters who are over 50% likely to be correct, the closer to 100% you get that the majority will be correct. In fact, for the example you just shared, it only takes a group of 11 voters with a 60% chance of being correct to be better than a single voter with a 75% chance.
Only 11? That is much fewer than I expected.
Me too, which is exactly why it's important for people not to delegate too much in liquid democracy.
I mean, for sure. But do we know anything about delegation rates for liquid democracy?
We do, thanks to Victoria and her collaborators who recently conducted research where they could study this.
We ran 2 different experiments. One was a very classic lab experiment, and one was an online experiment.
The lab experiment had a straightforward setup. There were 2 boxes, one with a prize, and the participants had to vote on which had the prize. Before they voted, they were all given information about which box had the prize, as well as how reliable that information was, as well as how reliable the information of the expert that they could delegate to was. And they found...
So in this experiment, we find that people really have a tendency to delegate too often.
It's like the reverse of Dunning-Kruger. They probably had the same intuition that I had earlier.
Most likely. But what's really interesting is that the pattern didn't hold when it came to people abstaining from voting. which is similar to delegating, except instead of giving your whole vote to one person, you are really giving each other voter a tiny bit extra weight.
And what's interesting there is that people abstain the theoretically correct amount. If you consider in the equilibrium where majority voting with abstention does best, they abstain that amount on average.
Which means
liquid democracy does poorly if you compare it to majority voting in terms of how frequently we get the correct outcome in the lab due to this overdelegation.
Well, that's too bad.
It really is, but those results were from the lab, and we both know that results from the lab do not always translate to more real-world scenarios.
But one concern we had was that because of the really precise environment of the lab, where you know your own precision, you know the expert's precision, all very precisely, that this might be distorting behavior because it might be driving people to really focus on the contrast between how likely their own signal is to be correct and how likely it is for the expert's signal to be correct.
Which is why they did a second experiment.
And what we wanted to do in this online experiment was to make the precision of the signals very ambiguous.
Yeah, okay, that makes sense. So what did the experiment actually look like?
In order to make the numbers ambiguous, they used a test from psychology that's based on perception. Essentially, there were a lot of moving dots on a screen. Most are darting about randomly, but some are moving as a group to the left or to the right. Everyone gets a quick look, about 1 second, and then they have to vote on the direction. So no one knows exactly how accurate their sense of the direction is, and while again, they can all delegate, this time instead of knowing how precise the information the person who they're delegating to has, they just know that they were among the top 20% of correctness among the participants in prior rounds.
And how did the delegation look in this new experiment?
Well,
even in this environment where nobody knows any numbers at all, we still get that people delegate in some sense too often. They delegate more often than they abstain. And it leads to liquid democracy doing worse than they would have done if they had just done majority voting and gone with what they each reported as left or right in each task.
Great. So should we just be writing liquid democracy off then? I mean, I only just learned about it, so I can erase it pretty quickly.
I don't think we're quite at that point yet. It definitely raises some concerns about delegation and the non-intuitive nature of when to do it that proponents of liquid democracy will have to address. It is important to note that these experiments were precisely set up, which makes for good science, but does mean that they can't test everything, which is why Victoria says,
I think there's certainly more research that needs to be done.
It's also important to remember that in politics, there is not always a right or wrong answer. And the way people actually picture liquid democracy is quite different from the way they tested it.
You know, a lot of people talk about, oh, what I want is to be able to delegate basically on this one issue. I delegate to the politician I agree with on environmental issues, and they vote on all environmental issues for me. The idea is people want to pick for a given issue someone that matches their preferences, but then has more information.
Yeah, it almost feels like a fluid House of Representatives instead of a
Yes. I think that's how a lot of people would envision it. Yeah.
Exactly. That's just the sort of thing I was picturing. I could vote on the bills that I thought were so vital that I had read and researched them. But for the rest, I could choose a delegate depending on who I trusted for that topic.
Me too. I even sort of imagine in a liquid democracy that there would be people who end up as a new profession who sort of serve as professional delegates who read all the bills and have known ideologies, except instead of electing them and they get to have our vote delegated to them for the length of their term, we can give and take it freely.
Yeah, I mean, that sounds quite good, except for one thing.
What's that?
Yeah, how are they getting paid?
I'll get back to you on that. All of that said, I won't hide that I find liquid democracy to be a very intriguing possible path for how governments could be run in the future. The arguments from its proponents that it could increase public participation in the democratic process, as well as responsibility and cooperation with respect to public works, are quite convincing to me. But I really hope that the research Victoria says is needed happens, because the results she helped find have made me a lot less bullish than I used to be.
There's many other reasons people might argue for liquid democracy, but the informational grounds that are often one of the first reasons it's pushed, we have reason to be a little concerned about that.
Yeah, hopefully that research that Victoria needs actually happens and it can provide more clarity.
Definitely. There is one thing that I'm clear on, though.
What's that?
It would still be better than plurality.
Oh, of course. We have plenty of clarity on that.
And if you are not as clear on that as we are, Ismar has a kind offer.
Yes. If they're not, they need to email me and I can talk to them some more.
Don't forget to check out our show notes in the podcast description for more Ismar and Victoria, including links to their work we discussed on the episode.
And if you like the show, give us a review on Apple Podcast or Spotify or wherever you listen. By rating and reviewing the show, you really help us spread the word about Carry the Two so that other listeners can discover us.
And for more on the math research being shared at IMSI, be sure to check out our homepage, imsi.institute. We're also on the site formerly known as Twitter at IMSI_Institute, as well as Instagram at IMSI.institute. That's IMSI spelled IMSI.
And do you have a burning math question? Maybe you have an idea for a story on how mathematics and statistics connect the world around us. Send us an email with your idea.
You can send your feedback, ideas, and more to HansenSM at IMSI.institute. That's HANSENSM at IMSI.institute.
We'd also like to thank Blue Dot Sessions for the music that we use in Carry the Two.
Lastly, Carry the Two is made possible by the Institute for Mathematical and Statistical Innovation, located on the gorgeous campus of the University of Chicago. We are supported by the National Science Foundation and the University of Chicago. Another is the Majoria.
Masks of Majoria criteria.
Yep.
Sorry, I'm done. I can understand that. After all of this, anything that is not I can't say that word. Plurality, save me, Jesus. Okay.